indefinite integral of 1/2 times the cosecant squared of x minus the cosecant of x times the cotangent of x dx. And I'm going to break this up a little bit, trying to decide how to do it. So we'll say 1/2 times the integral of the cosecant squared of x dx. I'm going to distribute that 1/2 through that difference. So we'll have negative 1/2 times the indefinite integral of the cosecant of x times the cotangent of x dx. So now this is a constant, so it's going to sit there for now. The functions whose derivative is the cosecant squared of x is the negative cotangent of x. So that's going to be the negative. Ooh, why did I put an s there? I don't know. Let me erase that. Negative cotangent of x. Remember, the derivative of the cotangent is a negative cosecant squared of x. So if we put this negative here, then when we take the derivative of this, we'll get the positive cosecant squared of x. So that's where that negative comes in. And you can always just look at the formula that I have over here to the right, the non-zero constant being 1 in this case. So now we have negative 1/2 times the function whose derivative is the cosecant of x times the cotangent of x. Well, that's the negative cosecant of x, and then plus our arbitrary constant c. And that negative comes into play the same reason this one did, is the derivative of the cosecant of x is the negative cosecant of x cotangent of x, which I guess we could have actually left this negative in, but I don't know. Sometimes when you get better at this, you'll do things like that. But there's a little bit too much mental leaps going on there, so I just went ahead and did it this way. So the derivative of the negative cosecant of x is the positive or is the negative times the negative, negative 1 times the negative cosecant x cotangent of x, which is the positive. So anyway, we'll just clean this up, and we get negative 1/2 cotangent of x. Negative 1/2 times the negative 1 is positive 1/2 cosecant of x plus c. And I guess you could rewrite that in some ways, although in this section I really don't think you need to find common denominators with these trig functions. I don't think there's really any reason to. I would just leave the answer like this. That's a little too complicated, but you do have cosine over sine and 1 over the sine, so you got a common denominator and you got 2, so you could actually rewrite this if you really wanted to as 1 minus the cosine of x divided by 2 sine of x plus c. I really don't know, but your book might put it this way. I'm not sure. It might. But yeah, the cotangent is the cosine over the sine. So that's where you get this negative 1 cosine, and then you would have 2 sine in the denominator. And here you have 1 over 2 sine in the denominator. And so you get it right here. And I was just making sure it wasn't theta. So I don't really know. Yeah, a lot of times we're just happy if you can get it to this point. But sometimes solutions manuals go ahead and put it in this form. I probably should have been thinking about that in previous examples, but oh well.